Assalamu alaikum. My name is Nimra Meen. I am the student of MS Chemistry at the University of Management and Technology. Today, the topic of my presentation is development of nanostructured cathode material for high performance lithium ion batteries. I am going to deal these main heading in my presentation. First of all, I will talk about the lithium ion batteries, then we will see the working of lithium ion batteries, then nanoscience, development of nanomaterial, and at the last we will look at the application of nano-size cathode material. First of all, we will see the introduction of the topic. So as we all know that lithium ion batteries used to store energy. But to enhance its performance, we used nanostructure cathode material, and I will explain nanostructure is useful to increase efficiency of lithium-ion battery and how we can develop it. First question arises in our mind, that is why we need of nanostructure cathode material. So the reason of this, because the number of population is becoming increases day by day, not only just in Pakistan but all over the world. And now people moving toward the city area, so urbanization rate is increases. Demand of electricity is also increased, so it is a big challenge and demand to store energy. Energy is in Energy demand is increases day by day. The use of fossil fuel vehicle to be replaced more with more efficient and environmentally friend, environment friendly electrical car. As we earlier we use fossil fuel vehicles, but nowadays we replace these fossil fuel vehicles with more efficient and environment friendly electrical cars, which store energy in the form of electronic devices and is need to be efficient like fake, not oversized, and has high performance with its growth. Another problem is, as the oil demand is also increases and associated price is also increased, and environmental issue are continuing to exert pressure on an already stretched world energy infrastructures. Now we will see lithium ion batteries. Lithium ion battery is an advanced battery technology that uses lithium ion as a key component of its electrochemistry. Here the component of lithium ion batteries has basically four components: cathode, second one is anode, electrolyte, and that the last separator. A lithium ion battery is a rechargeable battery in which lithium ion move from negative electrode to positive electrode during charging or discharging process. Here there is two type of batteries. First one is primary batteries and second one is secondary batteries. Primary batteries single use devices and can't rechargeable. And secondary batteries are those batteries which are rechargeable batteries and can be rechargeable again and again. So it's mean lithium ion batteries basically are secondary batteries. As we talked earlier, lithium ion batteries can be recharged again and again. Here the component of lithium ion batteries: cathode is made up of lithium cobalt dioxide and anode is basically made up of graphite, electrolyte lithium salt with organic solvent, and separator basically is semi-permeable membrane. Lithium ion batteries first layer is basically lithium cobalt oxide is used in first layer, which is structural cluster and has been produced commercially. But here there is some advantages of lithium cobalt oxide, that is it was expensive, it is toxic, it is explosive in critical conditions. Electrolyte play an important role in lithium-ion batteries. Lithium-ion has highest tendency to lose electron. As we know that there is only one electron present in its outermost shell, so it is easy for lithium to lose this one electron and become more stable. So we can say that in pure form lithium is reactive because it is easily react and give one electron and become stable. But when it is in combined form, or when it is in lithium is a part of oxide, it is quite stable. In lithium ion batteries reaction at cathode, there will be formation of lithium cobalt dioxide, and reaction at cathode there will be lithium ion and graphite with losing one electron, and overall reaction lithium cobalt dioxide and graphite will be formed. When provide electricity, lithium ion move from anode to cathode during charging process. And when we provide negative current, it means lithium ion move back from cathode to anode. And this process will called discharging. Lithium ion batteries are capable of having a very high voltage and charging storage per unit mass and unit volume. So that's cover everything I want to say about lithium ion battery. Now move toward my next topic, which is nanoscience. The definition of nanoscience: research of the different behavioral property of element on nanoscale at nano level shows some properties which are charging with changing nanoscience structures, and it will permit more functionality, and the properties are conductivity, which may be thermal or electrical, then strength, magnetism, and reflectivity. Example of nanoscience is nanotransistor, which is used in computer industries and has a in small in size but has great features. Basically, it is small microchips. Batteries with nanoscale material deliver more power quickly with less heat. Properties of nanoscience material: at nanoscience properties of material will change from bulk material. When we will move toward at nanoscience or nanoscale, bulk changing their properties. So the properties of nano material is different from bulk. Large fraction of surface atom, high surface energy, spital confinement, reduce imperfection. These do not exist in the corresponding bulk material. As we talked earlier that at nanoscale, nanomaterial change their properties from bulk material. Advantages of using nanomaterial in electrodes of lithium-ion batteries. Surface plays an important role in increasing the capacity of nanoelectrode. It means lithium-ion surface is important in storage. A high electrolyte contact area can also lead to improved high current or discharging capacity, and these points are based on these considerations. If the material has particle with fine size, it means it has short transport length. Then it will make full lithium diffusion possible within a short diffusion time. Using electrolyte can greatly reduce the specific current density of active material because of very large surface to volume ratio. Short path length. During this, basically these are the factors which may affect the efficiency, which enhance its ability to store energy, which make the lithium ion batteries more efficient. So second one is short path length. During lithium charging or discharging process, there will be reduction or oxidation reaction, while lithium ion and electron transport take an important role. Nanostructure material can provide short path length, code both lithium ion and electron transport. Nanomaterial size electrode material are necessities for high power and high energy density storage and conversions. Nanostructure electrode for stable cycle. The capacity fading of lithium-ion batteries upon cycling is usually caused by the large volume expansion or contraction associated with lithium insertion or extraction, or lithium alloying or lithium dealloying. Lithium insertion or extraction inevitably introduce cracking or crumbling of the anode material and cause loss in caliphate during cycling. Nanostructured electrode can absorb this large volume expansion, contraction, or pressing if the integrity of the electrode lead to stable check performance. Here, the real life example is Tesla cars, smartphones, power tools, and the objectives are low cost, high energy density, and large life. Nano 1 coated single crystal cathode material. Government and multinationals are fueling the transition to a low carbon economy at the core of this transition. Our renewable energy electrical vehicle and batteries is push is in for extended range, faster charging and even million miles batteries. These batteries work by shuttling lithium ion battery, cathode and anode material during charging and discharging, but performance is limited by durability of these materials. Lithium cycle is and out of the cathode through a large cluster of crystal, but cathode are prone to side reaction in the batteries impacting safety, durability and longevity. Coating can be applied to surface of cluster crystal as protection against unwanted reaction during complexity and the cost of the manufacturing process. And repeat charging damages the coating as cluster of crystal expand, contract, and break apart, leaving the nano-sized crystal within the cluster exposed to side reaction. Single crystal cathode are less prone to cracking. We can be formed with extra heating to coating, but this adds even more cost and complexity. Here, the solution of this problem is that all these problems can be solved by forming a single nano-sized crystal and a coating simultaneously. It begins with nano patent in pot reaction where lithium is mixed in a single reaction with coating and other metal feedstock to produce a composite precursor powder. When heated, it transforms into coated single nanocrystal with no extra step, no extra excess heat, no added cost. Nano ones coated crystal technology and durability for long-range fast charging, automotive nanomaterials, batteries, enable high voltage ultra fast charging of cobalt free. Lithium ion solid state batteries bring power and cost advantages for heavy duty IFP applications. Developing of nano-sized cathode material for magnesium ion batteries. Here the advantages of using magnesium ion as an anode, that is, it is very affordable and abundant, safe process, large volumetric capacity as the magnesium has 3833 megahertz per centimeter cube capacity, volumetric capacity, but the lithium as compared to magnesium has less volumetric capacity. Nanostructure cobalt as negative electrode material for the next generation lithium-ion batteries. In 1990, the first lithium-ion battery by Sony have been considered. Nowadays, Nano put batteries research into spotlight, including electrical vehicles and stationary grid storage for wind and solar electricity generation system. Battery cathode material applications. Battery cathode material for automotive, consumer, and industrial application is growing to $23 billion. Rechargeable lithium-ion batteries work by shuffling lithium between cathode and anode, making the modern electrical vehicle a energy dense cathode power are made by breaking a lithium ion into large composite particles of energy metals such as cobalt, nickel, and manganese. Most cobalt is found of Congo, making it expensive and hard to get car manufacturer. Aborting nickel ratio to reduce cobalt. This increases energy but decreases stability, and safety industry is developing coating to help protect the cathode, but coating add cost and break apart from repeating charging. For individual coating, nanocrystal resist cracking. Now it's time to sum up my presentation. So conclusion of all these presentation is that we have reviewed some advantages of nanostructured electrode material for high rate energy storage devices, especially for high rate lithium ion batteries. Of course, there are some advantages such as more complex synthesis process for the nanomaterial, which will increase the cost of lithium ion batteries. Therefore, the next challenge will be to develop simple synthesis method for large scale production of nanostructure active materials. Thank you so much.